Hi and welcome to Cherry Pie Math. This video is going to go over how to solve word problems involving inequalities. And to start, here are just some things that you should know before getting into it. So you should know how to set up two-step equations and how to solve them. And you should also know how to solve inequalities with variables, and that includes what to do when you have negative coefficients. And I have some other videos and I'll link them here as well so that you can go back and review as necessary before we get into the word problems. Okay, so some tips, and I've made other videos with word problems before, and the first one is always to draw pictures, and I cannot stress this enough. When you draw pictures, it gives your brain a chance to organize all the information that you're being given, and that's why you're told to take notes in class and draw diagrams, is because if you just hear it, it doesn't really accomplish a whole lot. You need to be able to organize the information in order to make sense of it. So first, draw pictures or do something that will organize your information. Second, you need to figure out what your variable is going to be, and usually that's in the last sentence. So one trick I always did was I would just read the last sentence first and figure out what my variable was, and that would help me kind of make sense of the rest of the problem. Write down what you know. I've seen some students be like, what we know and what we don't know, and then they write like a list. I personally don't do this because usually if they give you a number, you just have to use it eventually. But if it helps you to do that, then you're more than welcome to do that. These are the two biggest things, the minimum and maximum, that are really more applicable to inequality word problems. When someone says you need a minimum of this, it means that X has to be more than whatever the minimum is. Okay? Whereas a maximum means that your value has to be less than whatever your max is. So for example, let's say you have a budget of $1,000. That would be this one. You would be saying how much it costs has to be less than $1,000 because that's my maximum. But like, let's say I need to have a minimum of 4 sales. I would say any number above 4, because 4 is my minimum, would be how you would set up the inequality. So just be really careful about minimum versus maximum, and you'll see also like at least or at most. Include units. Double check your answer, make sure that it makes sense. Like if you have a budget of $1,000 and the X you get is 1,050, obviously that's wrong because you can't have it more than 1,000, and most of the time it will be included, especially in word problems, because if you have a budget of $1,000, that means that you can also include $1,000, and that's totally fine. So most of the time it's going to be less than or equal to or greater than or equal to. So let's do some practicing. So a family is planning a Disneyland trip. Each day will cost the family roughly $800. What is the maximum amount of days they can stay if their budget is $4,200? So we have a couple of things. We have the word maximum, and we have the amount of days. So I'm going to use D for days. And we also know that we have a maximum, and remember that means that the value has to be less than my maximum budget, which we know is 4,200. So that means for every day, all of these 800 plus 800 plus 800 has to be less than 4,200. Whenever you keep each day at that same cost, you can really just say 800 times the variable, or 800D. So this would be my inequality. So just pause the video if you need to and make sure you know where all these numbers came from. The 4,200 represents my budget, and it is equal to, that's my bad, I forgot to include that. It's less than, or it's the variable. I always use a variable on the left side. The variable is less than or equal to, because this is a maximum budget. And it's 800D because it's 800 times the amount of days. And then from here, I can just solve it. So I would divide both sides by 800. And that would give me D is less than or equal to 4,200 divided by 800, which is 5.25. So let's just pause here. It says the maximum amount of days. So I guess they could stay for a quarter day. But the maximum amount of full days, we know that it has to be less than 5.25. So the max amount of days in the context of this problem, so the max days is equal to 5. The reason I say that is because we know that the days has to be less than or equal to 5.25, right? And the nearest whole number to that that's less than 5.25 would be 5. It can't be 6 because 6 is too big. So in the context of this problem, the maximum amount of days this family can spend is 5 days. So even if your answer comes out to be some kind of a decimal, it could be much uglier than this. At the end of the day, it's just whatever is the nearest whole number that fits in the context of the problem. So just be really careful about the context of the problem. So let's do another one. A jewelry store employee works on commission. They earn $10 an hour just for being at work. But for every sale they make, they earn another 20. If they work 30 hours a week, what is the minimum amount of sales they need to make to earn $400? Okay, so again, we want to identify some things right away. First, we know it's a minimum. So that means it's going to be the variable, and then it's going to say more than or equal to, because we want it more than the minimum amount. We know that the minimum amount is $440, and we also know that they work for 30 hours a week, and we're looking for the amount of sales. So I'm going to say S is going to be the number of sales. Okay. We know that they earn $10 an hour for being at work and that they earn $20 for every sale. We don't know the amount of sales, but we do know that they're working 30 hours a week. So I'm just going to do it off to the side here. I'm going to do 30, I'm going to make it a cross here instead. 30 times 10, because I know it's 30 hours times $10 an hour. So they're going to make $300 just for being at work. So I know it's $300 for being at work, and I know that for every sale they make $20. So I'm going to do 20S because that will represent 20 times the amount of sales. And then plus $300 because they're always going to have $300 just for showing up to work. And this is one of those things that will catch students as well, as they'll see, oh my goodness, there's a 30 and there's a 10. Oh my gosh. When you're setting up an inequality, especially if it says two-step inequalities, it's always going to look like this. You're going to have something here, the coefficient, that's attached to the variable. And since we knew the variable was the amount of sales, we knew that the coefficient had to be 20. And we knew there's also going to be this constant here. And that was how much they're just going to make always in a week. Okay, so let's go ahead and solve it. So I would subtract 300 from both sides. So now I have 20S, because that cancels out, is more than or equal to 140. And then I'm going to divide both sides by 20. That cancels out my 20, and I know S is more than or equal to 7. Okay, and because it's a whole number and it's included, I know that they have to make at least 7 sales. So I interpreted it in the context of the problem. And that's something else. Just always make sure it makes sense in the context of the problem. So take a minute and make sure you understand where all these numbers came from. This is the hardest part. Setting up the equation is the hardest part of a word problem. And this is what scares students the most, is because they have to translate between words and the equation. You can do it. You just have to take some time and make sure it all makes sense before you get started on solving. You can guess and check, but usually your teacher is going to be looking to make sure you can make something like this. And I know that in the Utah core, it actually says specifically you need to be able to build this kind of equation out of a word problem. So now you know. All right, this is the last kind of word problem you might come across. So the quotient of a number in 9 is less than -4. Give 5 possible values for the number. Okay, this is different because it's not an actual context. It's not a scenario. I'm just giving you clues to solve a problem. So let's go through what each of them mean. So a quotient means division, okay? And it says a number. So obviously the number is the variable because we don't know what it is. We'll just call it x. And 9 is less than -4. So if I do x divided by 9, that's going to be less than negative 4. It's not less than or equal to in this case because I didn't specifically say less than or equal to. We have 5 possible values for the number. So in order to start, we do need to solve for x. So to get rid of x, I'm going to multiply both sides by 9. Because that's how you would get rid of the 9, is you would multiply it. So I have x is less than negative 36. So if I was to draw it on a number line, I'd have negative 36 here, an open circle because it's not included, it's not equal to, and then it would be any number less than negative 36. Be careful because sometimes students will be like, oh, 34 is less than 36, but that's wrong. Because this is a negative number, negative 34 is actually over here. So we can say maybe, I don't know, like negative 38, negative 39, and really any number with a negative and then a absolute value larger than 36. So I'm going to say negative 38, negative 39, negative 102, negative 177, and negative 213. There you go. So those are some 5 possible values that fulfill this requirement. Not all of them are going to make integers. In fact, most of them won't, if any, but they do fit in this category, and it doesn't say it has to be a whole number. It just says it has to be less than negative 4. So those are some tips for doing it. So some biggest takeaways: pay attention to at least and at most, like the minimum, maximum. That's what's going to catch most of you. Also double check your answers. Make sure it makes sense in the context of the problem. And then one thing I forgot to write here is be careful of negatives. And I have this in my other video. But remember that if you divide by a negative or you multiply by a negative on both sides, you do have to switch it. So if I have like negative 3x is less than negative 12, when I divide both sides by negative 3, it actually makes the sign flip. And I go over that more in my other video. So just be careful about that. When you divide by a negative or you multiply by a negative, it just makes sure that the sign